The ant, seen on the right side of the maze, is a long way from home. Write a program to help the ant get to the ant's nest, the white square. So we can see the ant here. It is actually quite small, so I'll zoom in a bit. And we need to get it all the way to the white square. So these tabs, most of them we have seen before. So we've got movement, and this allows it, to move in certain directions. We can turn right or left and then keep moving. So let's just see. You can set the speed when you run the program. Let's set it to slow. So it's going to move forward twice, turn right, and then move forward. Now, the thing is, the ant is actually a very long way from home. So if we want the ant to get there and write some code that is efficient, well, it's going to be difficult to just keep writing different blocks to actually get it there. And this is partly because in here it's not always very obvious just how much it's actually going to move by doing one move forward. Let's try. So if we do 2 turn rights at the start to make it turn around and start facing the left, and then it's going to start moving forward. Let's make sure it's very slow, and you can see it's moving in the right direction. But we're going to have to write quite a lot of code and try so many moves and turns to be able to do this. Right, so here we see we hit a wall, and it's not even pausing at that end for us to see where it is exactly. So I had to do one more move forward before I turned left. So we need a more systematic way to get the ant to the white square. And this is where loops come in. So we've got these loops, which we can say, repeat some code a number of times. So for example, here, instead of doing move forward 3 times, well, I could delete these and I could say repeat 3 times. Let's even make it, let's do this. Let's even make it 10 times and see where that takes us. So it's getting us somewhere, and we can actually use these repeat certain number of times blocks to get us through the maze. But still, that's quite a lot of twists and turns, and it's not very easy to get to the white square. So what we're going to need to do is an even more systematic way. And this is a very, very important algorithm in pathfinding and solving mazes. What we essentially want to do is get the ant to the closest wall in the maze. Then we're going to say, stick to that wall and keep walking along that wall. And we can choose any direction, right? If we choose for it to go up from here and keep sticking to the wall, it's going to stick to this wall. And it's going to turn, keep sticking to the other side of the wall now. It's going to move this way, then to the outer wall. Turn here. And it'll keep going, keep sticking to the wall. Now, it is going to take longer for the ant to get there, but it's not a restriction in the question. There's no restriction on the time needed for the ant. What's actually important is, your time, the programmer's time, because this is a timed challenge. So if we can write more efficient code that eventually does get it to the white square, then we will do that. Well, let's think about how we're going to do this. We're going to start by first having the ant move to the wall. So that's 2 moves forward, and then we can either choose this route that I just showed, but let's try doing it the other way, kind of moving down and sticking along this wall, and you can check that eventually it does actually get the ant all the way to the white square. So it's going to get here and around, wrap around this wall, go up here, go to the corner, turn here, and get to the white square. So we're going to get it to this wall first. Then it's going to turn right. Remember that we're always considering the ant's perspective. If this is forward, then this is right. Moving this way, down from our perspective, is going right for that ant. So we're going to have it turn right and just check that we need one more move forward to get it to the wall, and you can see that actually it got to the wall and turned right. Now here we're going to make use of blocks like this. This means it's quite similar to, the if block we saw in the previous question, but this is more specific. The condition that it's checking here has to do with the fact of whether there is a path ahead of it or whether there's a wall. So here we're saying, for example, if I do if path ahead, move forward, what the ant does is it checks, is there a path ahead or is there a wall? If it's an empty space, it's going to move forward. If it's a wall, then it's going to do something else, and this is what I put in here. Well, we're going to use this to do this systematic way of wrapping around the wall. Now, this algorithm we commonly refer to as the left-hand rule, which means the ant, as it's moving along, will always check if it can go to the left. That's always going to be its main priority because the wall is on its left. If it can go to the left, it will. If it can't go to the left, it's going to keep moving forward. So, if it starts over here, it checks, can it go to the left? Well, there's going to be a wall, so it's going to move forward. Can it move to the left? There's a wall, so it moves forward. Can it move to the left? No. Can it move ahead? Well, also no in this case. So what we need to then account for is if it can't move left and it can't move ahead, then it has to move to the right. So let's try this. We're going to say, if there is a path to the left, then what you're going to do is turn left and move forward. So let's see where that takes us. Right, it stops straight away because actually there's no path to the left. So let's say actually if there's no path to the left, move forward. And you can see this time it moves that one extra step forward. And we wanted to repeat this decision-making process. We can use a repeat certain number of times, but we don't know how many times it's going to require the ant to make this decision before it gets to the white square. So in the movement tab, there is a repeat do. So every time it's going to repeat everything in here. So it's going to check, is there a path to the left? If there is, turn left and move. If there is not, just move forward. And this makes the ant get to this point. But you see, it gets stuck over here because we still haven't added that condition we spoke about, which if there's no path forward, then turn right. And this is where we're going to have to do a neat trick, which is we're going to add another one of these in here. If there is a path to the left, turn left and move forward. Else, so if there's no path to the left, if there is a path ahead, move forward. This is basically like the else if that we did in the previous question. So we could do it by doing the if, and else, but this just makes it easier because it includes checking for paths within the block. So if there is a path to the left, turn left and move forward. If you don't find a path to the left, check if there's a path ahead. If there is, you're going to move forward. Else, so this means if you couldn't find a path to the left and you couldn't find a path ahead, well, what you're going to have to do is turn right and move forward. And let's check what this does. We're going to need to stop the execution and run it again. And you can see this time it actually turned right. Here, it turned left as soon as it could, because that's always the first decision it makes. The priority is always to going to the left. As long as it's sticking to the wall, there is no left. If it hits a wall, there's no path ahead, so it's going to turn right. So here it's just moving ahead. It's doing this, basically. And now it's gotten to this point where it turns right. Now it does turn left twice. And it keeps sticking to the wall. Let's make it a bit faster. And it does exactly what we want it to. It sticks to the wall and gets to the end point. Now, the nice thing is, as we said, that we could have done this the other way around. So instead of turning right when we got to the wall, we would have turned left. And since we're going this way, the first priority should be checking if we can move to the right. If not, we move ahead. If neither of those is an option, we go to the left. So we're going to change around some of these. Priority is if there's a path to the right, move to the right. Else, if there's a path ahead, move ahead. Else, so that means there's no path to the right and there's no path ahead, you're going to turn left and check what this does. It moves along the wall from the other side. Now this is exactly the same idea, but we call this the right-hand rule, because it's always prioritizing going to the right. And you can see that even though it might take the ant longer to get there, it took us a much shorter code than if we had done specific instructions for it to actually go through the maze and get to the white square.